Welcome to the third video in the series of videos on solids. In this video we are going to look into we are going to do problems together, and we're going to focus especially on the strategies to solve the problems, right? So I'll guide you through a step-by-step process, and I urge you to pause the videos wherever it's required and try it yourself before you proceed with checking on the solutions. That'll be more meaningful for this video. So let's do the first problem. So the first step we have to do in any such problem is a visualization. So I would urge you to pause this video here and try to draw the given information and try to represent what is being asked. So pause the video here. So here is a drawing or visualization of this problem. So we have three cubes joined together to form a cuboid. The length of this cuboid we can find is 24, and this is your breadth, and this is your height. So we have all these things given, and it's been asked to find your total surface area. So we know that the total surface area would be the area of all the faces, that is 2 times L into H plus H into B plus L into B. That is 2 times 24 into 8 plus 8 into 8 plus 24 into 8. Yep, you can take 8 common here, so that'll be 2 into 8, 24 plus 8 plus 24, sorry. So that's 2 into 8 into 56. And that'll be about, you get it as 896 centimeters square. So that's your answer. So how the problem is solved once we are able to visualize how the given information should need to be represented. So let's now try to visualize the next problem. I urge you to pause the video here and try to draw and see or represent the given information. So pause the video here. So here is the given information decoded or written in the form of a picture. And what you can see is everywhere where we have converted meter to centimeters for convenience, and represented all the information: the brick, the wall, and the fact that 1/9 of the wall is cement and sand. So we need to find the total number of bricks. So we know, the first thing is total number of brick is equal to total volume of the wall divided by volume of each brick, right? So let's say volume of bricks in the wall. By volume of each brick. So first let's find out what is the volume of each brick. So volume of each brick is 20 into 8 into 16 lbh centimeter cube. So it is good not to multiply it yet. It's always better to kind of do all numerical operation at the end together, since many things may cancel out. So second is, what is the total volume of wall, right? So this is a tricky one. So the way to go about doing this is, we can say, hey, the total volume of the wall in this case is total area, which is in the front that you see, the total area without the doors and all those stuff, into the depth, which is 30 centimeters, right? Which is 30 centimeters. So once you find the total area, it's just you're stretching it backward by 30 centimeters. Now how do you find the total area? 30 centimeters. So once you find the total area, it's just you're stretching it backward by 30 centimeters. Now how do you find the total area? It's just you're stretching it backward by 30 centimeters. Now how do you find the total area? 30 centimeters. So once you find the total area, it's just you're stretching it backward by 30 centimeters. total area would be the area of the full wall minus area of the, so area of wall minus area of doors, right? And that's equal to area of the wall is 3000 centimeters into 500 centimeters minus 250 into 120 centimeters into 2, because you have 2 doors here, right? So this is a classic example where your exponents will come really handy. So you have 3 zeros and 2 zeros, so we can say that it's 15 into 10 power 5 centimeters square minus, you have 250 into 2 is 500. 500 into 120 would be, you know, the easiest way to do 500 into 120 would be multiply both sides by and divide by 2. So that'll be you can cancel this and say 60. So this is 2 into 500, that's 1000, so it's 60,000. So you can say 6 into 10 power 4 centimeter square. This amounts to 150 minus 6, which is 144 into you know, let me write the steps. This is equal to 150 into 10 power 4 minus 6 into 10 power 4, that is 144 into 10 power 4 centimeter square, right? That's a total area, and your total volume is area into 30, so 144 into 10 power 4 into 30 centimeter cube. So now that we got the total area, by the way, we get this total volume, this thing from this equation, right? Once you find out the total volume, we can find out the number of bricks. So you have 144 into 10 power 4 into 30 centimeter cube divided by 20 into 8 into 16. So now we can again try to cancel out things. This goes, and the denominator would be 144 by 16 squared, right? 144 into, let's say, 100 into 100 divided by 16 into 16. Now here we can write 144 as nothing but 12 into 12. Writing it as 12 into 12 would make sense, because we can now easily cancel this. So this is 3 into 4, this is 4 into 4, this is again 3 into 4, and this is 4 into 4, right? Once you do that, you have 9 followed by 4 zeros divided by 16. Oh, we missed a fact that 8/9 of the wall is brick. So total volume is this much, total number of bricks would be 8/9 of that, right? So this is into 8 by 9 times. So that's important, because so we missed that 8 by 9 times. Okay, so we have now this into 8 by 9 times, and that will amount to, cancelling this, you'll have 10,000 divided by 2, and that will be equal to about 5,000 bricks. I guess I missed out this 3 as well, so I have to write into 3 as well, so sorry about that. So into 3, so that's 5,000 into 3, and that'll amount to 15,000 bricks. So yeah, that's a lot of numericals in this problem. I guess it's a tough one. So this is about 15,000 bricks that you need for that construction. So as you can see, the most important thing in this problem is to visualize what is given, and the first step that we did, that is half the problem solved. So once you visualize and strategize what you need to do, then I think the answer is rest of the answer would be trivial. Okay, let's do the next problem. So I would urge you to visualize this problem again and try to come up with a pictorial representation before we solve this. So pause the video here. So here's the visualization of the problem. You have a square, a rectangular container with square base, 15 into 15 centimeters, filled with liquid, and it has water up to 3 centimeters from the top. So this is not 5, this is about 3 centimeters from the top. So that's 3. And as you put a cube, it's said that 54 centimeter cube of water spills. So let's try to decode this and write in terms of mathematics. So the volume of the cube is your x cube. So when you put x cube into water, the 54 centimeter cube of water falls down, plus the water, before the water falls down, the water level rises from this mark to the top mark. So that much volume would be, the volume of air or whatever was there, right? So that's 54 plus that be 15 into 15 into 3, this into that height. That would be this volume where the water has filled in after you put in the cube. That's equal to 54 plus 225, and that's equal to, oh sorry, it's not 225, it's 15 into 15 into 3, so it's 225 into 3. So that would be 729 centimeter cube, or in other words, your x is 9 centimeters, right? Cube root of 729 is 9 centimeters. So the questioner is asking find the volume of the cube. So that's obvious. The volume of a cube is 729 centimeter cube. What is the surface area? We know the surface area of a cube, all the 6 sides that the cube has, and that's 6 into 9 squared, and that's 486 centimeters square. So here again, I think the key of the problem is your starting point, where how you visualize this whole thing. So I hope you enjoy this video. See you in the next one. Bye.